Grade 5 pupils, we're going to be looking at completing the square. What we mean by completing the square is to have a quadratic and to write it in this particular form. The question will either ask, write a given quadratic in this particular form, or the phrase completing the square will be used. Okay, but this here should be recognisable. So completing the square came up in National 5, so previous examples there. Within higher, the main difference will be our A value will no longer be a positive 1. It can either be a value greater than 1, 2, 3, 4, 5, or a value smaller than 1, negative 1, negative 2, negative 3, etc. Okay, our method, we'll first of all remove a common factor. What this allows us to do is to create a quadratic within brackets that you can complete the square just as normal as you would have done previously in National 5, and then we will simplify our expression at the end to get it back to our desired form. Okay, so a few examples that's going to take us through complete the square. So in question 4, the very first thing I'm looking to do is going to take out a common factor, and to get it as nice a way as possible, all I'm going to do is put my descending powers first. So minus x squared plus 10x plus 12, not done anything other than change the order, and that allows me to take out a common factor of the negative. Gives me negative 10x minus 12, gives us that expression there. And what that has allowed us to have is a quadratic within those brackets. And what we're looking to do is just complete the square within the brackets, and we'll deal with the negative at the end. Okay, so as we would have done previously, I'm looking to represent those red brackets. Let's extend that out ever so slightly. So at x squared minus 10x within the red brackets will be written in a different way, and that minus 12 will not be touched at all. Okay, so from there, my completed square form puts my x squared and x term within this squared bracket. As previously explained, we take the minus 10 and we half it, and we take away that value squared. So minus 5 squared is 25. Process every time. So whatever the x coefficient is, half it, take away the square. Okay, if I combine the minus 25 and the minus 12 together, I'll get my completed square form. But I've got this negative outside. It actually works in my favour to multiply through at this point with my negative. And you'll see a wee bit more the reason why in our next example. You could combine the minus 25 and minus 12 and then do the negative. But if we do it in this sense, we have minus x minus 5 squared. That's just minus through actually 3 sets of brackets, or 2 sets of brackets to get in front of the third bracket. Minus, and then the minus 25 becomes plus 25. And the minus 12 plus 12. And simplify now, minus x minus 5 squared plus 37. So I've completed the square to get into that particular form. What's significant about this is as we have a negative bracket, we have a negative x squared. So we have a maximum turning point. All the previous examples were minimum. At, and we can easily find the turning point. And we get this by solving the bracket. Five, and then the 37 just as it is. And that's us completed the square and also got the nature and coordinates of the turning point. Okay, question 5. So we have a coefficient of 2 in front of our x squared, so therefore we're going to take a common factor of 2 out. And we give ourselves a fraction, and that fraction will actually be carried the whole way and won't actually be touched. So my common factor of 2 out, my coefficient, and now within that bracket is a quadratic that we have to go through our completing the square process to then simplify at the end. So once again, there's my square brackets. So once again, I'm going to replicate that in the next line. As I said, that 5 over 2 is not going to get touched. So, rewriting x squared minus 4x in a completed square form. The x squared comes from the x there. And we take the minus 4. So minus 4 is the coefficient of the x. Half it to get minus 2. And we take away that squared. 4. So the two red brackets are exactly the same, just written in a different form. Okay, and this, when our decision comes about, we could combine these two terms if we wished. Minus 4 plus 5 over 2 wouldn't be overly difficult, and then multiply through by 2. But instead, I'm going to multiply through by 2 at this stage. And the reason for that is the 5 over 2 that I've carried down from the top will be multiplied by 2, and it gives me back to the 5. So I've actually not having to deal with any fractions in this case. So 2 lots of the bracket as I multiply through. 2 lots of the minus 4 gives me minus 8. And 2 lots of the plus 5 over 2, don't even need to think about it. I just get the 5 that I started with. At the beginning I took out a common factor of 2, and then I multiplied back through by 2. So I just always end up with that 5 value to finish. And then I can combine 2 lots of the bracket. Minus 8 plus 5 is minus 3. And that's me completed the square. Common factor out, complete my square within the bracket, simplify at the end. That there is a positive x squared. So I have a minimum turning point at, solve that bracket, two, and then I take the minus 3 to get my y. Repeated the square. Okay, next one. So very similar in this one. I need to take my common factor of 4 out from my coefficient of x squared. What that will leave me with is x squared, leave me with 3x. and it will leave me with 6 over 4. Could simplify that, but I'm actually just going to keep it exactly the same because it's not going to do anything. This one will be a wee bit trickier because of the odd number, so I will have a fraction within my completing the square, but again I'll multiply through by 4, just that step just towards the end, and then simplify. So there is my brackets, 4 lots of, keep that in there. Going to try and keep the red brackets identical and carrying that 6 over 4 whole way. My completed square form involves x, which will be squared, and to keep the two red brackets identical, I take the coefficient of the x, which is 3, and I half it, 3 over 2, and I take away that value squared, and if I need to do that at the side just to show, three squared is 9, 2 squared is 4. Square the top, square the bottom. So taking away that squared is 9 over 4. So again, if I wanted to, I could multiply these, I could combine these two terms. That would involve a wee bit of fraction work, or multiply through by 4. It's not guaranteed to get rid of the inside fraction. In this case, it will. 4 lots of the bracket. Minus 9 over 4 times 4. The 4's will cancel to give me minus 9. As expected, I'm back to what I'd started with, and then when I combine 4 lots of my bracket minus 15. Positive x squared gives me a minimum turning point at bracket solved negative 3 over 2 and minus 15. Okay, and final example, we've got a combination. We've got a negative x squared and we've also got a coefficient of 2. So I'm going to rearrange that to get minus 2x squared plus 10x plus 8. I'm going to take minus 2 out as my common factor. X squared minus 5x minus 4. And again, in that red is where I'm going to complete the square. Minus 2 lots. And once again, I've got minus 5 as my x coefficient, so I'm going to end up with some fraction work. So aiming for the two red brackets to be identical. The only way I can do that is to take my x coefficient minus 5, half it, minus 5 over 2, and take away that squared, square the top, square the bottom. And let's take that minus 2 the whole way through. Minus 2 lots of that first bracket. Minus and minus is plus. 50 over 4 plus 8. So I haven't managed to get rid of the bracket, the fraction, minus 2 lots of x plus, if I get 50 over 4, 8, if I put that over 4, top and bottom by 4 gives me 32, minus 2 lots of x minus 5 over 2 plus 82 over 4, and that will work out nice to carry a fraction. Certainly wouldn't be rounding it, but that will work out nice. So 82 over 4, 41 over 2, it's 20.5. So make sure that is either a fraction or an exact decimal, nothing rounded. And from there, that minus x squared is going to tell us it is a max turning point at solving the bracket 5 over 2, so x is equal to 5 over 2. And that is completed the square with a negative and coefficient greater than 1. And we have the PowerPoint for questions.